This little talk is all about ozone in the atmosphere and the structure of the atmosphere. The atmosphere is a layer of gases surrounding the Earth, and it's divided up into a number of different layers. The first of these layers, the layer that's closest to the surface of the Earth, the layer that we all exist in and most weather occurs in, is a layer called the troposphere. Above that layer is a layer called the stratosphere. The next layer is the mesosphere. And finally we have the thermosphere. And eventually the atmosphere becomes space as the concentration of gases gets lower and lower and lower. Inside the stratosphere you might notice there's a blue dotted line. That represents this layer called the ozone layer. The ozone layer is a natural layer of ozone in the atmosphere. It's in an equilibrium, and it's a very important layer because it actually helps to block UV light from the sun. A range of different lights comes from the sun, which look at the visible light spectrum. Red light can penetrate the atmosphere and reach the Earth's surface. Orange light can penetrate the atmosphere and reach the Earth's surface, and ditto for yellow, and ditto for green, and ditto for blue, and ditto to violet, and indigo and violet. And that's all fine for us, except that as these wavelengths are becoming more towards the blue end, they get more and more energetic. They're carrying more energy. And very high energy forms of light, such as we know X-rays and gamma rays, can cause cell damage and cell death and can lead to cancer. And UV light is one of those examples of a high energy form of light which can actually cause cancer. But luckily for us, UV light can't reach the surface because UV light is blocked by the ozone layer. It is stopped by the ozone layer. And that's very important because if we had too much UV light, life on Earth would be very different. It would be very difficult for us to survive. Some UV light does get through, but UV is mostly blocked by the ozone layer. So let's look at how the ozone layer blocks UV light. And ozone actually has two different aspects in the atmosphere. Ozone in the stratosphere and the ozone layer is very good, whereas ozone in the troposphere is not so good. We're going to find out why in a minute. There's a little saying that goes with that, is ozone is good up high, but it's bad nearby. And let's look at how ozone can be so good in the ozone layer and block UV. It's because it exists in an equilibrium. What happens is a series of reactions in the ozone layer. First of all, there is normal oxygen in the ozone layer as well. And when normal oxygen atoms are struck by UV light, they can decompose and turn into two oxygen-free radicals. And we know an oxygen-free radical is an oxygen atom that has an unpaired electron. Oxygen atoms actually have two unpaired electrons, which makes them very reactive. And therefore, if you have oxygen-free radicals in the ozone layer, or in that layer of the stratosphere, when they combine, or when they meet normal oxygen molecules, they'll actually react with oxygen molecules to form this chemical called O3. Some of these oxygen-free radicals do actually combine with ozone molecules and decompose the ozone back to oxygen again. And ozone itself, when ozone is struck by UV light, it absorbs the UV light and turns back into oxygen and oxygen-free radicals. So there's a series of reactions happening in the stratosphere, in the ozone layer, and these reactions are all in a natural equilibrium. Okay, so that means the rates of production and decomposition of these three different chemicals are in balance. The net result is, of all these reactions, is that UV is absorbed. And if UV is being absorbed, it doesn't reach it doesn't reach the surface of the Earth in the troposphere, which is where we are, which is very good because UV is quite damaging, as you'll learn as you do your studies. So that's why ozone is good up high. If we think about bad nearby though, ozone is actually a poison. It's an irritant. Ozone is toxic. It's toxic to life because it's highly reactive. Oops. Ozone is toxic to life because it's highly reactive. It interferes with respiratory systems, interferes with animals and plants, interferes with immune systems. So it's not good to have in the troposphere, but human pollution does cause it. One of the main pollutants caused by combusting fuel in a combustion engine, such as in a car, is nitrogen dioxide. Now, nitrogen dioxide, when it's hit by light, it can decompose. And when it decomposes, it can form oxygen-free radicals. Now, those oxygen-free radicals now in the troposphere can react with oxygen molecules in the troposphere, producing ozone. So that's why a problem called smog occurs in cities. And smog is air pollution, mainly caused by cars and trucks and their internal combustion engines, which results in the production of ozone in the troposphere. And ozone, being toxic to life and a respiratory irritant, can cause problems like asthma, and in serious cases it can cause death. So that's a summary of the structure of the atmosphere, the role of ozone in the atmosphere, both as being good up high and bad nearby.